Okay, you already learned about this similarity and dissimilarity. We know that the similarity often falls between 0 until 1, and the value is higher when the objects are more alike. So when the objects are similar, the value will be 1. But the dissimilarity, or we can say this is the distance, the lower when objects are more alike. So if it is 0, then the objects are more alike. The upper limit varies. It means the upper limit can be any numbers, can be 100, can be 1000, can be 1 million, and so on. So the proximity, it refers to similarity or dissimilarity. So there are two things that we will learn during this chapter. The first is about the data matrix. The data matrix is the same with your initial materials. We can have row. So this is the row 1, the row 2, row I until row n. We can say this is n data points. And we have p dimension. This is the dimension 1, dimension 2. We can say this is the f dimension or the dimension f, and we have until the p dimension. And we call this is two modes because we have the x and y. We can also have this similarity matrix. This is the combination. We have n data points. The data points means the row is still the same, but it registers only the distance. Later we will check D21. It means the distance between the point 2 and 1. If it is the 1, this is 1, this is 2, this is 1, this is 2, then this is 1, this is 2. This is the distance between point 2 and point 1. Here, if it is 3, then this is the distance between point 3 and point 1. It can be represented using a triangular matrix. So this is triangular because later we will learn that the D21 will be the same with D12. So we can just consider only the triangular. And usually we can say this is single mode. If we want to see the proximity measure for nominal attributes, you know, nominal attributes. Nominal, it is the category, okay? Categorical attributes. And these categorical attributes, it is unordered. There is no order. Okay. For example, we have two or more states like colors: red, yellow, blue, green. We can measure the proximity or the similarity using the simple matching. The simple matching means, let's say I have the object 1, I have the object 2. And I have the attribute 1, attribute 2, attribute 3, attribute 4. The person 1 is now wearing red shirt, black pants, white shoes, and yellow hat. The person 2 is wearing blue shirt, black pants, white shoes, and orange hat. So if we need to measure the proximity or the distance between I, which is this object, and j, which is this object, then we can calculate using this formula, p minus m divided by p. P is the total number of variables, and m is the total number of matches. Let's see this one. How many variables do we have? 1, 2, 3, 4. So the p equals to 4. How many numbers are matches among 4? 2. Okay, black and black, white and white. So m will be 2. Then we can fit into this formula 4 minus 2 divided by 4. Then it is 0.5. Okay. So the simple matching, we can see that the distance is 0.5. This is by taking 2 or more states for nominal attributes. But we can also have another way or method 2 if we use a large number of binary attributes. In this case, first we need to create a new binary attribute for each of the m nominal states. Based on the previous data, you can see that the person 1 is wearing the red shirt. So we change this red shirt into the column. So the shirt is red. The person 1 is 1 because the person is wearing the red shirt. The shirt red equals to 0 for the person 2 because he or she is not wearing the red shirt. On the other hand, this one is 0, this one is 1 because the person 2 is wearing blue shirt. Here the black pants are 1 for both subjects. Both subjects have the same white shoes, but the head person 1 is yellow and the person 2 is orange. So using this kind of binary values, we can also measure the distance. So let's say this one, the distance is 1, this is the distance is 1, this is the distance is 0, 0, this one is 1, and this one is 1. And there are many ways to calculate the distance between these two objects. So later on, we will learn more. We have proximity measure for the binary attributes. You still remember binary attributes? We have just 2 values. Thank you. We have only 2, whether it is 0 or 1, or it is yes or no, okay? Or it is positive or negative. Okay? We can create the contingency table. The contingency table for the binary data. Let's suppose I have the object j and I have the object I. So if the object I is 1 and the object j is 1, then we can measure the frequency. So we can see the frequency. Q is the frequency that object I is 1 and the object j is 1. R is when the object j is 0 and the object I is 1. S is when the object j is 1, the object I is 0. And T when both of them are 0. So we can measure the distance if it is symmetric binary variables. What is symmetric? What is symmetric? So there is no difference between two values. For example, gender, male and female, there will be no difference. Okay. We can use this formula, R plus S divided by Q plus R plus S plus T. What about if it is asymmetric binary variables? What is asymmetric? Yeah, there is a difference between the two values. For example, if you have a positive COVID-19, then it is more important than the negative. Okay. Positive COVID-19 is more important than the negative. So we will check if the R and S axis, so we will divide with the Q, with the R, with the S. So we will not consider the negative. The negative means the 0. Okay. So the 0 will not be considered, or it is the T. Okay. We will just have the formula R plus S divided by Q R S. There is another measure, we call it Jaccard coefficient. This is also a measure or similarity measure for asymmetric binary variables, and similarity using the Jaccard can be noted with this formula, Q divided by Q plus R plus S. So let's see this example. Let's measure the distance measure for the asymmetric. Okay, asymmetric. We have name, Jack, Mary, and Jim. Gender, we have male, female. Viewer. So yes, yes, yes. Cough is no, no. So N means negative, negative, positive. So there are other tests which P is positive, N is negative. So the remaining attributes are asymmetric binary. Gender is symmetric attribute. Okay, so gender is symmetric. We can just remove it. We want to measure the asymmetric binary variables. So let Y and P equals to 1. So Y and P equals to 1. And N equals to 0. So how can we know the similarity between the two objects? I would like to check the distance between Jack and Mary. First, I need to create the contingency table. One, 0, 1, 0. And let's suppose this is Jack and this is Mary. Okay. Because this is symmetric, we will not consider it. Now let's see. Jack is Y and Mary is Y. Y equals to 1. So it means both of them are positive, or both of them has fever. So 1 and 1, there will be 1 item. N. So N equals to 0. Then 0 and 0, there will be 1. Test 1, we have P and P. So positive and positive. So positive is 1. Then we have 1 and 1. So there are 2 for this cell. We have n and n. So 0 and 0. Then we have 2. Now Jack is n negative, but Mary is positive. So Jack is 0, but Mary is 1. Then we have 1. And then the last one we have n and n. Negative and negative, which is 0 and 0. So we have 1 more here. So we can calculate. We have 3 items here. We have 2 here. We have 1 here, and we have 0. So we can calculate based on the formula, which is R plus S divided by R Q plus R plus S, which is the R. So I guess this is R plus S. So 0 plus 1. 0 plus 1 divided by Q plus R plus S. Q equals to 2 plus 0 plus 1. Then the result is 0.33. This is the similarity between, this is the distance between Jack and Mary. Let's see the distance between Jack and Jim. Again, we can create the contingency table. This is 1, this is 0, and this is 1, this is 0. And let's suppose this is Jack. And this is Jim. So we have Jack, we have Jim. Gender, we will not use it because it is symmetric. Fever, okay, both of them, they have fever. Yes, so we have 1. Jack has no cough, but Jim is positive for the cough. So Jack is 0 and Jim is 1. So we have 1. P and N. So Jack is positive, which is 1, and Jim is negative, 0. So we have 1. N and N. Jack is N, Jim is N. Jack is N, Jim is N. So we have another 3. So at the end, we have 3 items here. We have 1, we have 1, and we have 1. And we can just put into the formula R plus S divided by Q plus R plus S. R is 1 plus 1, okay, 1 plus 1 divided by Q. Q is 1 plus 1 plus 1. Then we will get the distance is 0.67. Okay. So can you calculate the Jim and Mary? Okay, you can try. You can try later. Okay. That's for the categorical data. In the categorical data, we have 3 kind of data: the ordinal, nominal. We have ordinal, nominal, and binary. Okay. For the ordinal, we have different ways. Okay, we cannot measure the proximity because if it is in the order, yeah, we will have difficulties. So that's why there is only the way to measure the similarity between nominal and binary. In numerical data, we can measure with the dissimilarity matrix. Let's see this one. We call this is the data matrix. Data matrix. We have 4 data points. We call this is point. We have 4 data points, and we have two columns. We have two attributes. The first data point, x1, have attribute 1 equals to 1 and attribute 2 equals to 2. So it is 1, it is 2. So this is x1. What about x2? x2 has the attribute 1 is 3 and attribute 2 is 5. So 3 and 5. So here is the x2. x3, we have 2 and 0. So 2 and 0. This is x3. And x4, we have 4 and 5. So this is the x4. We can create later the dissimilarity matrix. So this is the dissimilarity matrix. We call it, this is the dissimilarity matrix with Euclidean distance. So we will check how we can calculate it. We have the Minkowski distance. Minkowski distance, it is the distance for numeric data. Minkowski distance is a popular distance measure, and we can calculate the Dij with this formula. So let's suppose I have this data. I have object I, and then I have object J. And I have the attribute. What I can do with this one is to do the square root based on the its. Its is any value. I will explain later. And the formula will be the xi1 minus xj1. So this is the column 1. We will do subtraction from this value and this value. And then we will do the power of its plus xi2 minus xj2. So xi2, xj2. So this is the column number 2. And so on until the column P. Until the column P. And we still do the square or the exponent its. So we have two-dimensional data objects. 2p-dimensional data objects. It means we have 2 rows and we have 1, 2, 3 until p dimension. And its is the order. So the distance so defined is called L its norm. There are 3 properties. First is the distance I, j is higher than 0 if I not equal to j and di, I is 0. It means that if we have x1 and x3 like this one, of course there is a distance. So the distance will be higher than 0. If it is the same object, so di, I, so if it is the same object, then the distance will be 0. For example, x1 and x1, the distance will be 0 because it has in the same location. Dij equals to dji because this is the symmetry properties. It means we have the x2, x1, so we have 3.61. This value will be the same with this one. x1 and x2 will have the same value with the x2, x1 like this. So this is the symmetry. And the other properties is Dij is less than or equal to dik plus dkj. So let's suppose I have I here and I have j here. The distance from I to k plus k to j, it will be higher or equal to the dij. So it will be equal to or higher than dij. Because this is the triangle inequality. Because we can see this kind of triangle. So it can be something like this. For example, I here, j is here. Okay. We can have k here. So k here, of course, it is higher than the dij. Okay. A distance that satisfies these properties is a metric. So we call the metric distance for the numerical data. So let's see the special cases of Minkowski distance. This is the whole formula. If the h equal to 1, we call this is the Manhattan distance, or sometimes people say it is city block or L1 norm, because h equal to 1. If h equal to 1, then the square root, we call the square root because it is the basis of 2. But if it is 1, then it means we do not need to do the square root. So the square root will disappear, and then the xi1 minus xj1 power of h. When h equal to 1, then it is power of 1. Any number power of 1 will be that number. So we can just use the formula by absolute xi1 minus xj1 and so on. This is when the h equals to 1. When the h equals to 2, we call it this is L2 norm or Euclidean distance. So the formula will be the square root because h is 2. And then we have xi1 minus xj1. Since h equal to 2, then we will do square. And so on. We can have h as the infinite. When it is infinite, we call it is supremum, or we call this is L max norm, or we call it this is L infinite norm. This is the maximum difference between any component or attribute of the vectors. So we want to find the maximum after we do the absolute between the object I and the object J. Let's see the example. We have the 4 points. We have x1, we have x2, x3, and x4. So the x1 is 1, the attribute 2 is 2. We want to check the distance between x1 and x2 using the L1 or Manhattan. If you look at the formula, the Manhattan is just using the absolute. So what is the distance between x1 and x2? We will do the absolute. The absolute of 1 minus 3 plus the absolute 2 minus 5. Okay. Then 1 minus 3 is minus 2 because we have absolute, so this is positive 2 plus 2 minus 5, it is minus 3 because we have the absolute, then it is positive 3. Then the result will be 5. The distance 5 will be applied to this cell. Now let's see another example. I want to see the distance between x2 and x3. So I can do the absolute again. 3 minus 2. 3 minus 2 plus absolute 5 minus 0. 5 minus 0. And we have 1 plus 5. So the result is 6. And 6 is the value for the x3 and x2. So and so on. So you can measure for every possible x1 and x2, x1 and x3, x1 and x4. We can put here 5 and 3 and then 6. So we don't need to put the value here because it represents the same 5 and 3 and 6. What about the Euclidean distance? The Euclidean distance for x1 and x2, it means we have 1 minus 3, and then we will do the square plus 2 and 5, 2 and 5, and then we will do the square. So 2 power of 2 is 4, and we have 3 power of 2. So 4 plus 9, it will be 13. Based on the formula, we need to do the square root. So the formula mentioned that we need to do the square root. So this is also the square root. The square root 4 plus 9. So this is the square root of 13. If you look at your calculator, okay, then you will get 3.61, the square root of 13. Okay. So that's why I mentioned to you last time, you can bring your calculator when you do your exam. I can give you this kind of problem. So you need to measure. Okay? You need to calculate the distance. If you need to calculate the square, yeah, I guess it is difficult if you have like this number. So you need to use calculator. Okay. What about supremum? So the supremum means we want to get the maximum. Let's say I want to check the distance between x1 and x2. So the x1 and x2, we have 1 minus 3. And then we want to compare with the 2 and 5. 1 minus 3 with absolute, it means we have 2. 2 minus 5, it is minus 3. When we have the absolute, then it is 3. Based on the formula, we want to know which is the maximum. Okay, 2 and 3, which is the maximum? The maximum is 3. Then we put 3 as the distance between x1 and x2. Let's see another example, x2 and x3. So we have 3 and 2, 3 minus 2, and then we have another which is 5 minus 0. So 3 minus 2 is 1, and then 5 minus 0 is 5. We want to find the maximum. The maximum between 1 and 5 is 5. So 5 is the distance between x3 and x2. Okay. We have another similarity, we call it cosine similarity. So the cosine similarity means that we want to represent with the term frequency. A document can be represented by thousands of attributes. Document means like news, articles, something in the blog, or anything. It's recording the frequency of a particular words, maybe the keywords or the phrase in the document. I have document 1, let's say, and in the document 1, I measure the frequency of the word theme. Okay, there are 5 times. So in my document, there are 5 times the word theme. And there are 0 times for the word quotes. There are 3 times of the word hockey. There are 0 times of the word baseball. There are 2 times of the word soccer. 0 penalty, 0 score. There are the word 2 for win. And there are 0 and 0 for loss and season. So based on this number, this is the factor, because this is the factor objects. The factor object is the collection of numbers. We can have the other factor objects like for the gene. Some application, it can be for the information retrieval, it can be for the biologic taxonomy, or it can be for the gene picture mapping, and etc. So the cosine measure means we have 2 documents, D1 and D2, and they are in the 2 factors. We have term frequency factors. So the formula is like this one. Cosine D1 and D2 equals to D1 multiplied by D2, or it is the factor dot product, divided by length of D1, length of factor D, length of D1 multiplied by length of D2. Let's see the example. So I use the document that we saw before, and let's find the similarity. I want to find the similarity between document 1 and document 2. So this is document 1, this is document 2. So the document 1, we can create the factor 5. It is from this 5. 0, it is from this one. Yeah, okay. 3, this one. 0, this one, and so on. So we put all the numbers as the factors here. And D2, we also put the numbers here. So we have D1 here, and we have D2 here. Now we can do the product. Product means multiply. So we can multiply 5 multiply 3 plus 0 multiply 0 plus 3 multiply 2 plus 0 multiply 0 plus 2 multiply 1, 0 multiply 1, 0 multiply 0, 2 multiply 1, and so on until the end. And we can get the value 25. What is the length? The length means I would like to do the similar to the Euclidean distance, but I just want to see based on this document only. So here we have 5 multiplied by 5. So it means 5 power of 2, 0 power of 2, and then 3 power of 2, and so on. And we will do the square root. So power 0.5 is the square root. After we do the summation, we will do the square root, and this is the value. This is the length of the document 1, and this is the length of the document 2. Now, let's get back to the formula. So the cosine will be the D1 multiplied by d2 divided by the length factor of d1 multiplied the length factor of d2. Then we can just include the numbers. 25 divided by 6.481 multiplied by the 4.12. Then this result will be 0.94. Okay, so this is the cosine similarity between two documents. We can say that those two documents is similar because in the concept of similarity, the higher number is more alike. The higher number is more similar. Okay, learning check. Can you mention the difference between similarity and dissimilarity? For the similarity, the higher value is more alike. Okay, and usually we have the value between 0 and 1. The dissimilarity, the lower value is more alike. So closest to 0 is more alike. And upper limits are varied. It depends on the data. If your data is about income, maybe there will be a big distance. How many are there for the special cases of Minkowski distance? Yeah, 3. Okay, thank you. We have the h equals to 1. We call it, this is the Manhattan distance. Or we call this is L1. No. We have h equals to 2. We call it, this is the Euclidean distance. Or we call it, this is L2. No. And we have the h equal to infinity. Or we call it, this is supremum. Or we call this is L max. No. Okay. So hope you remember with this concept. Okay, let's have a break. I will continue after the break.